The race to build human-shaped robots is speeding up. Everyone wants to claim their part in the future of intelligent machines that look and move like people. Once these robots can truly think, the real question won't be which jobs they'll replace, it'll be which roles we're ready to give up ourselves. At Tesla's all-hands meeting in 2025, Elon Musk made his plan clear. He wants 5,000 human-like robots made before the year ends. He called it the first Legion. That number is expected to grow 10 times larger by the next year. What sets Musk's plan apart isn't just the number of robots he wants to make. It's the endless ways he imagines using them. In the beginning, these Tesla robots will only work inside Tesla factories. But at last year's We Robot event, we saw them serving drinks, dancing, and even having small conversations with people. That doesn't mean the current Tesla bots can actually do all those things just yet, they had some help during the demos. But it does give us a glimpse of what Musk has planned for them in the future. He wants these bots to go into disaster zones where it's too dangerous for people. He even plans to use them as part of the SpaceX mission to land on Mars. The current model, called the Tesla Bot Gen 3, has come a long way since it was first shown. Back then, the robot was just a person in a tight suit pretending to be one. But now the robot is real. It stands around 5 feet 8 inches tall, weighs about 125 pounds, and moves with the help of 28 different motors or actuators that allow it to mimic human motion. The robot's hands are one of its most complicated parts. They can move with up to 22 degrees of flexibility. For comparison, a human hand has between 23 and 27 degrees of motion. So pretty much anything you can do with your hands, the Tesla bot will also be able to do, and maybe even better, with exact precision. It has 8 cameras built into its body and is controlled by Tesla's full self-driving artificial intelligence system. What makes Tesla special is not just the technology, but also the big vision and in-house abilities that make this dream real. Tesla has spent many years training its AI systems using data from millions of real cars on the roads. And because Tesla knows how to build things at scale, it can make its robots inside the company and test them while they actually help build Tesla cars, or possibly, even build more robots like themselves. Back in 2024, the total market for humanoid robots around the world was worth just over $10 billion. That number is expected to grow massively, up to nearly $39 billion, by 2032. And that's not because of one company alone. Breakthroughs in AI, robot design, and vision technology are happening faster than ever. The cost to make these machines is dropping while the demand for them keeps going up. And now in 2025, the first real results are finally coming off the assembly lines. In Norway, a startup called 1X is already sending out a human-shaped robot named Neo Gamma into actual homes. They hope to deliver hundreds or even thousands of units by the end of this year. Another company, called Figure, might not be a household name yet, but they grabbed attention when they launched a new robot last year that used OpenAI's ChatGPT to give it a voice and allow it to talk with people. The conversations were a bit slow at first, but their latest AI system, named Helix, is a major step forward. Helix gives the robot the ability to understand what's around it and pick up or move objects it has never seen before. All of this is leaving the lab and going out into the world. The company is now making plans to build 12,000 robots each year and wants to produce 100,000 of them in the next 4 years. A year ago, those numbers would have sounded impossible. The heart of their success is the Helix system. It's not just one AI, it's a 2-part robot brain. The first part handles vision and speech. It uses a large language and visual model with 7 billion parameters. This means the robot can understand what it sees and what it hears. The second part handles movement. It uses an 80 million parameter motor model that takes the information the first part understands and figures out exactly how to act, like how to grab something, reach for it, or move around a space. One part sees and understands. The other moves the body. Together, they allow the robot to interact with the real world almost like a person would. With 35 degrees of movement, the robot can flex its fingers, swing its arms, and walk wherever it needs to go. What's even more impressive is that Helix was trained using just 500 hours of really high-quality data. That's very little training time compared to other AI models. For example, it took the same of about 10 years' worth of training time to build GPT-3. But Helix is already showing it can handle tasks it wasn't directly taught how to do. In one test, a figure robot using Helix was told to organize a refrigerator, no special training, no clear step-by-step guide, just a few words, and its own knowledge. And it did the task. Not perfectly, but well enough to amaze the people watching. It was the kind of moment that makes you wonder what the next version of the robot will be able to do. Unlike other companies that depend on cloud computing and remote servers, Figure made sure that Helix runs inside the robot itself using strong built-in GPUs. That means it doesn't need constant internet access, and there's no delay. You take it out of the box, and it just works. Maybe most surprising of all, Figure ended its partnership with OpenAI. They didn't want to rely on someone else's AI. They wanted their own system, something they control completely. While Tesla is focused on producing as many robots as possible, and Figure is focused on making them think and act more independently, NVIDIA is creating the basic tools and systems for everyone. Think about what Android did for smartphones, that's what NVIDIA wants to do for robots. They have a project called Groot, named partly after the Marvel character, but it also stands for Generalist Robot. Groot is a base model trained to do a wide range of real-world tasks. It can adjust to new situations as they happen. NVIDIA trained it using three main types of data: real-world sensor data, computer-made virtual environments, and huge collections of video from the internet. Groot works like a base-level brain that can be added to any humanoid robot. It uses two kinds of thinking. The first is reflex, fast reactions, like instinct. The second is reason, the part that takes time, looks around, and figures out plans. Together, they allow the robot to think in a flexible and smart way, choosing what to respond to quickly and what to think about more deeply. NVIDIA didn't just release this model, they're building an entire system around it. They made Groot open source so that developers all over the world can use and build on it. They created tools like the Groot Blueprint that can make training data quickly and at a huge scale. They even partnered with Google DeepMind and Disney Research to make a new physics engine called Newton. Newton helps robots move more realistically in digital spaces before testing them in the real world. For the hardware side, NVIDIA also made special chips called Jetson and Thor. These are powerful enough to run Groot in real time, inside the robot. And they're fast. In one test, Groot created over 780,000 training samples in just 11 hours. Normally, that much data would take weeks to gather. Groot did it in half a day. NVIDIA isn't focused on helping just one company. Their aim is the whole robot industry. Their customer list includes nearly every major name: 1X Technologies, Agility Robotics, Aptronic, Boston Dynamics, Figure AI, Fourier Intelligence, and Sanctuary AI. If you're building robots in 2025, chances are you're using NVIDIA's tech somewhere in your process. For a long time, companies like Boston Dynamics and Unitree focused on one big goal: making machines move like humans. Turning clunky, slow robots into fast, smooth ones that can jump, turn, run, or even do backflips meant solving very hard physics problems. But they've done it. Boston Dynamics is seen as one of the most respected names in the robot world. The company came out of MIT back in 1992. Their first big robot was Big Dog, released in 2005. It was a robot dog meant to carry heavy loads for the military. It had impressive strength, but its gas-powered engine was too noisy. That project ended in 2013. But 3 years later, Boston Dynamics made Spot, a smaller, quieter, electric robot dog. It was even sold to the public starting in 2020. The price? Around $74,500, over $90,000 in today's money. That's what it cost to buy a robot dog that could open a door. In 2013, Boston Dynamics also announced their first human-shaped robot, Atlas. It was powered by hydraulics and designed to help in search and rescue operations. Since then, it has improved a lot. Last year, they revealed a brand new version of Atlas. It's now fully electric like Spot, and its ability to move like a person, but with even more strength, keeps getting better. Over in China, a company called Unitree is getting ready to show off its newest humanoid robot, the G1. It's fast, affordable, and its movement looks very natural. It's made for mass production and is expected to make its big debut at the 2025 Robotics Summit and Expo. Early sneak peeks show a robot that can turn smoothly, stay balanced, and even hold tricky poses. A different company, called GXO, is already using robots made by Agility Robotics to work inside warehouses. These machines unload packages, move boxes, and work alongside people. In industries where it's hard to find enough workers, this is a big help, a robot that never gets tired, never gets sick, and never needs a break. The same goes for healthcare and elder care. As populations grow older and caregiving needs increase, humanoid robots are starting to take over routine tasks like fetching supplies, checking vital signs, or helping people move. They don't replace kindness or empathy, but they do take pressure off the people who provide care. In places that are too dangerous for humans, like nuclear plants, burning buildings, or chemical spill areas, robots are not just helping. They are starting to take the place of humans entirely. What makes a machine humanoid isn't just having arms and legs. It's about how it thinks and reacts. Because while plastic bodies can be shaped like people, copying how people behave is much harder. Today's humanoid robots are starting to use general-purpose AI systems. These models are designed to learn and understand. They can follow spoken instructions, see the world, and even do tasks they were never specifically taught how to do. Imagine trying to explain how to load a dishwasher to someone who's never seen one. You'd talk, maybe use hand signals, and point at dishes. That's what systems like Helix are learning to do, without needing prior training. For better or worse, we're now giving robots the tools to think in real time. As AI models like NVIDIA's GR00T become easier to use, robot makers like Boston Dynamics and Unitree no longer need to build their own AI. They can just use GR00T or something similar. That means the companies that already perfected how to make robots move may still lead the future, not because they cracked the AI problem, but because they already have the bodies built and ready. These machines don't feel. They don't choose. They're made to work. They're trained to adapt. And now they're learning to move through the world without us. Tesla is building them by the thousands. Figure is teaching them how to think. NVIDIA is giving everyone the tools. These robots aren't here to replace people, but they are changing what people will be needed for. And that change has already begun.